Our speaker today is Alan Steinman. He's from Grand Valley, and there he is the professor of, or the Alan and Helen Hunting director and professor at the Annis Water Resources Institute. You can read on the screen. He has his, he moved around a little bit for his education. He went to the University of Vermont for his bachelor's degree, Rhode Island for his master's degree, both in botany. And then he moved out to Oregon State, excuse me, and got his doctorate there. He has been director of the Water Resources Institute at GVSU for the past 20 years. He's published a number of scientific articles on his research into water problems. So I think without further ado, I'll turn it over to you, Alan.
Thanks, Kay, and thanks for the invitation and the opportunity to talk about this. The timing was incredibly fortuitous because today actually is World Water Day, and the UN's been doing this since 1993. And so today, the theme for today's World Water Day from the UN is valuing water, and hopefully we all value water, particularly for those of us living in the Great Lakes. But I want to focus on global issues. I'll also kind of bring it home as much as possible with examples. I really debated whether I should just talk about a few topics and go very deep, or talk about a lot of topics and go shallow. And obviously I decided to talk about a lot of topics and go shallow, as shown here. And these are the kind of topics that you can expect. Any one of these topics could be an entire class, if not an entire semester. So clearly, I'm not going to get into a lot of detail, but hopefully give you enough information that you can appreciate the nature of the problem, and hopefully some of the solutions that are lurking out there that we might be able to implement down the way. Let's start off with talking about the blue planet. It turns out that most of the water on this planet is in the form of salt water, 97.7%, and that remaining 2.3%, most of that is tied up in the ice caps and the glaciers, and it's not available. And then what's remaining of that small sliver is actually deep groundwater, which again is not obtainable. It's either too deep or it's already contaminated with either salt, because it's sitting on an ancient seabed, or maybe contaminated with naturally occurring radionuclides, which leaves 0.007% of all of the water on this planet that's available as fresh water. And by available, I mean it's in our lakes, it's in our rivers, it's in our shallow groundwater that's extractable and usable. We're very fortunate here in the Great Lakes to have 20% of the world's surface fresh water right in our backyard. How do we use water? On a global basis, the vast majority of it is used for agriculture, with 22% for industry and the remaining for domestic use. But when we break that down into developing countries, which would be classified as low and middle income, we see ag goes up from 70 to 82%, industry goes down, and domestic stays the same. And then if we go into high income countries, we see that agriculture drops precipitously. Only 30% of the water use is in agriculture, and almost 60% now goes towards industry, with a slight tick up in domestic use. So it really varies where we are, and the pressures on water quantity and quality vary as well on a global basis, which is something we tend not to think about very much because we're so focused here in our own backyard, which is a typical human behavior. We also need to think about virtual water, basically the footprint of how much water is used to produce or grow a product. For example, a cup of tea actually takes 9.2 gallons of water to produce. You think, well, it's only a cup of water. But in fact, to grow that tea bush requires a lot of water, and then to process the tea requires additional water. It's the same thing with a microchip. Actually takes 8.5 gallons of water. And then finally, a kilogram of beef actually takes 4,000 gallons of water. That's to grow the corn and to produce the beef from slaughtering the cow. So when people talk about water conservation and becoming a vegetarian, you'll know why, because it takes a lot of water to basically produce that 2.2 pounds of beef. Now, just some final facts that are very sobering. There's over 1 billion people on this planet that lack adequate drinking water access. which is defined as 19 liters per day, about 5 gallons per day. So that's where there's about 8 billion people on the planet today. So it's about 15% of the planet basically has less than 5 gallons per day. American, and a typical American, uses 150 gallons per day, and about 30% of that is used for outdoors. That's for, growing our grass, sprinkling our grass, watering our gardens, and things like that. When you think about it, when you think that we're using that much potable fresh water to sprinkle our lawns, only to cut them down the next week, it really is one of those processes that you've got to think future generations are going to look back at us and say, what the hell were we doing? And then 2.5 billion people, a third of the planet, lack basic water sanitation. And then more than 2 million Americans lack running water and indoor plumbing. That's a small percentage of the total American population of 350 million, but still, think about it. Here in America, 2 million people lack running water and indoor plumbing. So again, very sobering statistics. And I'm afraid throughout this talk, it's going to be somewhat sobering, but hopefully I will leave you with some glimmers of hope so that not everybody leaves depressed. When we talk about unsafe water sources around the planet, this is the number of death rates. This is basically per 100,000 individuals, and the darker the green, the higher the numbers. And it's largely sub-Saharan Africa. This is an area we don't hear about. If I list these countries that are facing these high death rates due to unsafe water sources, most of these countries never make it into the press. Bissau, Mali, Niger, Chad, Central African Republic, South Sudan, and Eritrea. I mean, we never hear about this, and yet there are hundreds of people, thousands of people dying on a regular basis in these countries. Now, the good news is that the number of people on a planetary basis that are having access to improved drinking water is basically, we're getting more and more people that have the ability to get safe drinking water. And that's largely due to the reductions we're seeing here in China, East Asia, and the Pacific. But we see sub-Saharan Africa is not benefiting as well. It's still increasing over time. But over time, we're getting more people that are getting access to safe drinking water. Another good news is that the total withdrawals from water on a planetary basis, that's the blue line up here, is declining over time. And that's largely due to the reduction in this yellow bar, which is thermoelectric power, as we're moving more and more towards alternative energy sources. But the other areas, public water supply, rural domestic supply used for livestock and agriculture, irrigation, and others, staying pretty constant over time. But overall, our water withdrawal use is being reduced over time, and that's great. Conservation is really critical. And we'll talk about that in more detail when I get to Ottawa County. So I'm going to move from these water stats into groundwater. People don't fully appreciate groundwater because it's out of sight and therefore out of mind, but 90% of our freshwater supply of water in this country is groundwater, 90%. We're biased here because we have so much surface freshwater in Michigan that we don't really appreciate how important it is. But it is important. It accounts for 20% of the total water use in the US, and there's 80 billion gallons are withdrawn daily in the United States. Over half of the Americans get their water from groundwater, and it provides more than 50 billion gallons per day in support of our agricultural production. So it's critical for industry, it's critical for agriculture, and it's critical for our drinking water. And most people don't really think about groundwater and how it truly exists. It's not the Jules Verne version as these underground lakes and rivers. In fact, when we look at groundwater, if we take this sediment core and we blow it up, we can see at the top we have this basically unsaturated area, or a vadose, and as we go deeper into the core, we have more water. And that water exists as basically water moisture between these soil particles. So we put a well down in there, we apply pressure with a pump, and we suck that water moisture out of the particles between, out of the water moisture between these particles. And the water basically exists in these aquifers. These are just geological formations where the water exists. And there are two basic types of aquifers. There's consolidated, which, as it sounds, it's basically what we call tight formations where the water is very low yielding. Basically, we're talking about things like granitic bedrock, and you can imagine that it's going to be very hard to get water out of that, as opposed to unconsolidated, which is loosely bound, and things like sands and gravels that we often get here in West Michigan in the top surface. That's the glacial till that we talk about. So let's take a cross section, and we can see here at the top surface, we have that basically the water table, that surface, which is high yielding. And then this unconfined aquifer where we can get our water from. And if it's near a pump, the water is moving in terms of days. If we get further away, it's in years. And then we have a confining bed, which is sometimes called an aquiclude. It's things like clays that really prevent water from moving up and down unless you dig a deep well. And in this case, if the pumps aren't going on, water moves in terms of centuries, and then we can go deeper and deeper. We're talking about thousands of feet now, where basically the water table moves in terms of millennia. You get polluted down here in the bottom layer, and it's going to take a long, long time for that pollution to move out of the system. And this is important because when we talk about the world's largest aquifers, over half of them are having water withdrawn faster than recharge can keep pace with the amount of water in that aquifer. And since groundwater provides so much water on a global basis, this has huge implications for where water is available in terms of quantity. We're not even talking about quality yet, just in terms of quantity. And where are these problems? Well, as you might imagine, the Middle East, northern India, and even southeastern US into Texas are basically taking water out faster than it can be recharged. And this is a problem throughout the entire planet. Here in Michigan, it's one of our most important natural resources, despite the fact that we can't see it. About 45% of Michigan residents use groundwater as their primary drinking supply, and we withdraw over 750 million gallons per day for agriculture, manufacturing, and other industries. Think about that, 750 million gallons per day of groundwater are being withdrawn. And it's a major contributor to our streams, inland lakes, and wetlands, and our coastal wetlands. In fact, in many cases, our rivers here have no other source of water than groundwater, particularly during the summer months. And it's what makes our blue ribbon trout streams so great. That cold groundwater is feeding into them on a constant basis and making a great trout stream habitat. Now, if we look at Michigan and we take a slice from the Upper Peninsula down to the Southern Peninsula, and then we rotate that 90 degrees, so we're looking at basically this cross section, we can see that the aquifers in this state are a series of nested bowls. And at the surface, that yellow surface is that basically the glacial till, which is sandy, high yielding. But as we get down lower, and it doesn't take very much to get down lower, we start getting into these other formations that don't yield as much and tend to be on the ancient seabed and can be saline. So we have to be careful how far we pump water out of these systems. Because just because we have a lot of water in the state doesn't mean that there aren't going to be competition in local areas where there are water conflicts. And we know about these water conflicts. Things like Ice Mountain in Mecosta County, where there's concern that we're drawing water out and we're harming the local aquifer in that region. In southern Saginaw County, some of the residents claim their well levels and water pressure have dropped significantly due to heavy irrigation during the summer months. And here in Ottawa County, we also have concerns over the static water levels dropping, and I'll talk about that in a minute, and contamination from fluoride. So let's talk about Ottawa County. We are facing a groundwater crisis, and it's particularly in the middle part of the county, where Robinson, Allendale, Olive, and Blendon townships merge. And the reason for this is, again, here we're taking a cross section of our aquifers. At the surface, we have this drift aquifer, the till area, and we can see it's pretty deep towards the lake. And then underneath that, we have a clay layer, that aquiclude that prevents recharge. And then below that, we have this Marshall Formation. Marshall Formation sits on an ancient seabed, and so the water in the Marshall Formation tends to be saline, has a lot of chloride. So as we start running out of water in the glacial aquifer, we're digging deeper and deeper wells, and we're starting to draw up water that has high chloride concentration. So there's a problem both in terms of water quantity and water quality in the county. And because we're one of the fastest growing counties in the state, the population pressures, the irrigation pressures are growing in the middle part of the county. If we look at the wells that have been drilled in this county along the lake shore, they tend to be in the shallow areas, the glacial till, which is relatively thick in this area, and we can get that water, high yielding water, out of the sandy areas. But as we head east towards Grand Rapids, we see more of the wells are now digging, have to go deeper. They're not getting enough water yield from the shallow drift aquifer, and they have to go down deeper, and they're pulling from the Marshall. And so if we look at this slide, we're looking over time, and on this top row, we're looking at the drawdown, and this is in meters. So the warmer, the hotter the colors, the redder the colors, the greater the water is being withdrawn from that surface level. And we can see in the middle part here, that red bleb, we're looking at water drawdown of over 50 feet over the last 50 years. 50 feet for the static water level to go down. And by static water level, what I mean is the amount of the water level in your well when there's no pumping going on. And that correlates very nicely with the amount of water usage, which is cubic meters per day. As you start pumping more water out of that, if the aquifer is not being recharged, basically your water levels go down. And this is what's happening in the middle part of our county. And here's that static water level, again, showing that in the 60s, we were up at this region, and now in the middle part of the county, it's dropped 40 to 50 feet in some areas just over the last 50 years. And so this slide basically has two data layers. I have that basically that orange and red in the background, which I just showed you before. So in the middle part of the county, we're drawing water down to that 40 to 50 feet. But superimposed on that are these dots, which are chloride levels in each of the wells. In Michigan, the threshold for chloride is 250 milligrams per liter. You don't want to exceed that threshold. And that's this dot here, that 250. And you can see most of these wells are now starting to draw chloride in above 250 milligrams per liter. Humans really, you can't really taste salt at that level. It's still low enough. It's really not going to be a problem. But if you're irrigating with salty water, it is going to be a problem for your soy, for your corn, and for your blueberries. So this is a growing problem. It's something that we're really concerned about in the county in terms of sustainability. And when you think about it, the issue, obviously, it's a technical issue, but it's also a psychological and social issue, because one of the easiest solutions for this is to conserve water. But when you're sitting in a county that's adjacent to Lake Michigan, how do you convince people that you need to conserve water when you've got such a vast array of surface water right in your own backyard? And if we look at this, this is the percentage of wells where the chloride levels are now exceeding that 250 milligram per liter threshold. And it's basically, I mean, it goes up and down, but the trend over time is increasing. And now we've doubled from 4% to 8% of the wells in the county now exceed that 250 milligram per liter threshold. So if we don't do anything, this problem is probably going to continue to increase over time. And it's not just Ottawa County. We're seeing this around the entire state, particularly towards the margins of lakes, in this case, Michigan, Huron, and Erie, because again, in these areas, that drift aquifer becomes thin as you go inland, and that Marshall Formation, which has chloride levels, tends to become more prominent. Ottawa County, to their credit, has been very proactive about this. We have been developing a water management and conservation plan. It includes education and outreach to let people know about the nature of this problem. It has water conservation strategies that we all can do as individuals or as different sectors of our economy. We're starting to set up monitoring wells and doing research around this, looking at policies to see if there might be ordinance changes that can be done, and then we're also looking at local land use and infrastructure planning. This website provides lots of great information in case anybody's interested in this, and I would encourage you to do that. They've set up an executive team, which includes members from all of the different sectors that are influenced by this, as well as some technical advisors, including myself. And so I give a lot of credit to what's going on in Ottawa County and their planning department for making these things move forward. One of the questions I often get when we talk about groundwater withdrawals is how problematic is the Ice Mountain withdrawal? And if we look at the major water users, the top 20 Michigan water users, most of this is industry and agriculture. In fact, Nestle Waters is actually number 85. So relatively speaking, they are a small water user on a statewide basis. That's not to say they aren't having an impact in a local basis, but clearly on a statewide basis, they are not responsible for our aquifers being drawn down statewide. So I just want to put things in perspective. So from groundwater to unsafe water, how safe is the water? And this has been a problem for a long time, and it's a problem globally. Here you can see in Botswana, elephants drinking toxic algal blooms and dying as a consequence. So it's not just in Lake Erie, it's not just in our backyard, but it's going on a global basis. But when we think about unsafe water here in Michigan, we tend to think about Flint and the problems associated with lead in that area. And this has been a problem a long time. I mean, even in ancient Rome, they recognized that lead was a problem. And Dioscorides in the second BC talked about lead makes the mind give way. So it's not something new in terms of us knowledge, in terms of our knowledge about it. What's new is how we've treated water over time. And what the major problem is, if lead is exposed to oxygen, it oxidizes and it releases these electrons, which then can cause corrosion in lead-lined pipes. And it can be controlled. And one of the ways that drinking water utilities control this is to add phosphate. Now, I know this seems kind of ironic because in many cases we're trying to reduce phosphorus in our systems, but in this case, in drinking water systems, you want to add phosphate because it basically forms this scale. It's a protective barrier. So it doesn't allow that oxidation to reach the lead pipe because that phosphate scale gets in the way. And when Flint was getting their water from Detroit, Detroit adds phosphate, so it wasn't a problem. But when they switched their water supply, they went to water that did not have phosphate addition. And there was high chloride as well. But now that exacerbated the problem, and it made the lead exposed to the corrosive forces of the electrons, which then would flake off the lead and put it into the water supply. And the crisis really emerges from failure to meet two different standards. One is the Federal Safe Drinking Water Act, and the second is local in terms of the Financial Stability and Choice Act, which led to emergency managers in our financially constrained communities. That Public Act 436 said if the municipality was experiencing fiscal distress, not just Flint, but here in West Michigan, it was Muskegon Heights and Benton Harbor as well, they would have a state-appointed emergency manager, which were left with these decisions where they really needed to get their finances under control. And when Flint met that criterion to become go under emergency management, one of the things they decided to do was to change their water supply in order to save money. The second problem involved the Federal Safe Drinking Water Act's lead and copper rule. And that lead and copper rule, the LCR, does provide water quality standards and treatment protocols for dealing with lead and copper. And the local utilities are required to monitor this, and they send their results, in this case to DEQ, or EGLE now, but back then it was DEQ when the Flint problem emerged. And then they send those data to EPA, and EPA is ultimately responsible for ensuring that the local utility is complying with the Federal Safe Drinking Water Act. So when Flint switched its drinking water to the Flint River back in 2014, the DEQ failed to require the city to treat the water for corrosion, in other words, to add the phosphate, to meet the Federal Safe Drinking Water Act standards. So the federal standards for lead in drinking water are 15 parts per billion. If you exceed that, it triggers this action level. In Flint, they had lead levels up to 13,000 parts per billion in homes, and yet enforcement actions were not triggered, which is, obviously a major flaw and tragedy, in fact. And now we see that former Governor Snyder, faces misdemeanor charges as a consequence, and the indictment that he's held under right now is he's been accused of violating the state constitution by failing to check the performance of public officials under his control. I don't want this to be political. I'm avoiding all political constraints. I'm just telling you, where we're at, why we're at where we are, obviously the real tragedy here is that the Flint people had to undergo this. And, it's not unique to Flint. This is certainly happening in other areas around our state, around this nation. In 2018, the state passed a stricter standard for lead. We are now required to notify residents within 30 days if they live in a house with a lead service line. All lead service lines need to be replaced in any communities that have lead by 2041. The local water system advisory councils are being formed to advise on community needs to make sure this isn't just a top-down driven process from Lansing. But if your water system serves more than 50,000 customers, these advisory councils are being formed so that there's local input, which I think is a great thing. The action level, the triggering action level, is lowered from 15 to 12 parts per billion. Of course, the key here is that an action is actually triggered, and that the state is paying $600 million to compensate Flint residents whose health was damaged by lead-tainted drinking water. Most of that money is going to the younger people, younger than 6 years old, and that's caused some concern amongst the adults who were also impacted. And whether that's enough money or not is another question. I'm sure that there will be additional lawsuits that will be filed as part of this process. And just showing you that this is not unique to Michigan or to Flint. It's going on all over the place. And as problematic as lead is, we do have solutions for that. They just need to be imposed. The next problem we're facing now is PFAS in our drinking water. And these are fluorine-related compounds. It's called the forever compounds because that fluorine-carbon compound is, that fluorine-carbon linkage is so strong, it's really hard to break down that bond. There's over 7,000 of these synthetic organic compounds that have been identified to date. And the two most studied PFAS compounds are PFOA and PFAS. So it's really easy to confuse PFAS and PFAS, but PFAS is the overarching name for all of these substances. PFOA and PFAS are two of the most common of the PFASs. The effects that happens in humans and animals, it changes our hormones and immune systems. It's been associated with decreased fertility. Immune systems have been suppressed, increases cholesterol in the blood levels. Certain types of kidney and testicular cancers have increased risks associated with thyroid disease and pregnancy-induced hypertension. So lots of different problems associated with it. Granulated activated carbon filters can basically filter out, screen out most of these PFAS compounds. There's different companies have improved carbon filters, either on a total house level or on a local level. You can put them into your sinks as well. I don't expect you to know these or even care about these specific PFAS compounds. What I do want to emphasize is that this is parts per trillion, all right? For the most common, PFOA at 8 parts per trillion. PFAS, 16 parts per trillion, very, very low concentrations. For the problems that were found in Rockford, in the House Avenue homes near the Wolverine plant, the PFOA and PFAS compounds were up to 57,000 parts per trillion. Just horrendous, horrendous levels up in those areas. We are changing our standards as a consequence. Water providers are required to test their water quarterly for these PFAS compounds. They don't test them for 7,000, obviously. That would be financially prohibitive, but there are 23 most common PFAS compounds that are being tested. Past testing by Eagle looked at 1,700 municipal water supplies. That's not individual domestic wells. These are municipal supplies. And they found that 90% had no reportable concentrations of these compounds. 7% had detections, but didn't exceed the 10 part per trillion total PFAS trigger level in any of the 14 they were studying back then. And then 3% had concentrations exceeding 10, but below the EPA guideline of 70 parts per trillion. The two water supplies that were most problematic were in Parchment outside of Kalamazoo, and then here in Robinson Elementary School, just east of Grand Haven, which were 70 parts per trillion, triggering a state response. And they still haven't been able to identify the actual source of that, but they've got filters in place. So switching to non-point sources of pollution, these are the most insidious because they don't have any federal regulatory authority. These are kind of the things that are coming from these excess fertilizers, herbicides, and insecticides, sediment running off our lands, livestock, pet waste, septic systems that aren't maintained, and oil, grease, and toxic chemicals that run off of our roads after stormwater events. 50 years ago, before the Federal Clean Water Act, 80% of our pollution came from point sources, out of pipes. After the Clean Water Act was implemented, now 80% of our pollution comes from non-point source because we've done such a good job of regulating point sources. So here's a great example of sediment coming off the Grand River going into Lake Michigan. One of the ironies of this, while the Grand River looks awful, Spring Lake never looks so good, huh? So, but this is a short-term problem. It's going to settle out into the lake. It's going to move around. Not much toxicity associated with this. Some phosphorus will be attached to the particles, but it goes away. But it looks god awful. So whenever we have these big events, it's going to be on the news TV. One of the problems that does occur with this runoff is the phosphorus, and that can trigger algal blooms. In this case, this is Spring Lake with a nice layer of microcystis on it. That is a potential toxin. And so we have to be careful when these form, these green patent formations. And microcystin, the most common toxin produced by these harmful algal blooms, is a hepatotoxin, so it can promote tumors. We have standards. The World Health Organization is 1 part per billion for drinking water and 20 parts per billion for recreation use. EPA doesn't have for drinking water, but it's forming it right now. It's going under guidance, and recreation is 8 parts per billion. We have this problem here in Michigan. I'm holding, this is Mona Lake, and of course, the western basin of Lake Erie is known for its toxic algal blooms. In Mona Lake, remember our recreational use threshold is 20. We were up to 350 in this bloom. Lake Erie in 2011 got up to 4,200 micrograms per liter. That wasn't the bloom that shut down Toledo's drinking water. The bloom in 2014 that shut down Toledo was, oops, sorry, didn't mean to do that, was only 1 to 10. But this bloom formed right at the intake for their drinking water, whereas this bloom was out in the lake, and it wasn't anywhere near the drinking water, even though it was much more toxic. So timing and space is everything. Moving to invasive species, we are the poster child here in the Great Lakes for aquatic invasive species, with over 180 that have been documented to date. They alter our food webs, as we well know, and there's huge economic costs associated with basically trying to get rid of them or keep them at a low level or prevent them to begin with. Zebra and quagga mussels are the ones that get the most attention for being here right now. And we can talk a little about them. Zebra mussels came in the late 80s. They kind of peaked in early 2000 and then started dropping off. These red dots are basically sampling sites that NOAA has. And the reason they dropped off is because their larger and more aggressive cousins, their quaggas, started taking over. The quaggas can grow in deeper water. They can grow on soft and hard substrates, whereas the zebras can only grow on hard substrates. So there's estimated now to be about 300 trillion with a T, quagga mussels in Lake Michigan. Basically, they're growing on top of each other in mounds that reach 6 feet high. They're so dominant. And because they're filter feeders, they're literally sucking the bioenergetic life out of Lake Michigan, having consequences for our food web. One of the big consequences, as they have started to dominate, they've basically resulted in the loss of this small scud or amphipod called Diaperia. And if you look at this, you can see those orange droplets in its gut, and this is all lipids, really, really good energy source. So if you're a benthic feeder, a benthic feeding fish, which eventually is eaten by lake trout and salmon, you want to have this energy source, not the Dreissenid mussel, which has a lot of calcium but not much meat. And as we've lost the Diaperia, we're losing some of that energy that's going up through our food web. And as a consequence, we're seeing the alewife is dropping dramatically. Now, most people, thinking back on how dominant they were back in the 60s and 70s and washing up our beaches, say this is a great thing. Who wants alewife? They're a problem. But in fact, the salmon want alewife. The salmon eat the alewife. And so when we don't have alewives, we don't have salmon. And so this heavily managed fishery in the Great Lakes is being affected very strongly by the existence of these quagga and zebra mussels. If we don't talk about zebra mussels, we talk about Asian carp. There are actually 4 species of Asian carp. The big head and the silver get most of the attention, but there's also grass and black carp that were native to Asia that have all been introduced to the United States. They were introduced back in the grass carp in the 60s, and then the others in the 70s, largely in fish farms down in the South, Mississippi, Arkansas, states like that, because these are filter feeders. They actually will go along and they'll basically eat all of the algae that were in these ponds, allowing the light to penetrate to allow the vegetation to grow, which is what the tilapia farms, the tilapia want to eat the vegetation. They don't want to eat the algae. But of course, what happened in the 70s, the Mississippi River flooded, and these fish farms all of a sudden became hydrologically connected to the Mississippi River. The fish escaped, and they've been swimming upstream ever since. And this just shows you some of those areas where of escapes down in Arkansas and Mississippi and Alabama that have gone on as they've continued to migrate north up the Mississippi and Illinois rivers. The bighead they are big. They can get up to 100 pounds. And as I mentioned, they are planktonic feeders. They'll feed along the water column. The silver carp are the jumpers, and we'll see if this works. I have a very short video, but it's kind of fun to watch.
We fished about as many places as we could fish in 2 days. We hooked 2. Saw some incredible country, but I guess do as the locals do. Tomorrow we're gonna go after some Asian carp. Start doing some figure 8s, and we're gonna try to put the big bear in the air.
All right. I'm sorry, I have to laugh because I actually have slides of guys standing on the bow of a boat in armor. Now think about that. You're in armor, and what happens if you fall off the bow? I mean, you can only hope these people haven't reproduced yet, because that's not the genetic pool that we want to have promulgated in our system. Silver carp, they double, at these enormous rates, which is why they're such a problem. They're currently, the carp are now, they're at this boundary about 50 miles south of the electrical barrier, and I'll talk about that in a second. And the reason why they haven't been able to get closer to Lake Michigan is because there is this pollution front at that area of the Illinois River, where it appears that the pollution is preventing the carp from moving any further north. So it's one of these situations, very ironic, where the pollution is actually serving a beneficial purpose. The Glimmerous study by the Army Corps of Engineers was basically to provide a range of options and technologies to basically prevent these aquatic nuisance species transferring between the Great Lakes and the Mississippi River basins. So we have an electrical barrier set up in Des Plaines. It's about 20 miles south of Chicago. And ironically, the electrical barrier was originally set up not to keep the carp from getting into Lake Michigan. It was set up back in the 60s to prevent the round goby from getting from the Great Lakes down into the Mississippi River basin. And so, of course, now it's serving a dual purpose. The Glimmerous study basically took the option where this Brandon Road lock and dam would be built. And we still have the electrical barriers in place. In fact, a third electrical barrier was added. But in addition, now there's going to be these air bubbles that are going to be basically, the bubbles act as a shock wave to prevent the carp from moving up. There'll also be acoustic sound waves being added, carbon dioxide being flushed into there, and the electrical barriers. So we have multiple approaches through this process in order to prevent the Asian carp from migrating up into the Des Plaines River and into the Chicago Sanitary Canal. So lots of different activities are going on down there right now as construction is going on, all in the hope to prevent this. We need to show them some love, but obviously the long-term solution, is how do we prevent them from getting in, and how do we detect them efficiently? And environmental DNA, where we sample the water for eDNA using next generation gene sequencing, is probably the best technique that we have currently to prevent, to make sure if we do see them, we do something immediately to go in and try and wipe them out. So it really is going to take a lot of prevention and detection to keep them out of the Great Lakes. Moving to microplastics, how do we define them? They're less than 5 millimeters in length. As you can see here, very, very small. These nurdles, which are basically the microbeads that form additional microplastics. There are secondary ones that break down of the primaries, the larger stuff like buoys and water bottles. And then there's pyroplastics that seem to form from burning of plastics, because incineration is a major way that people are getting rid of the plastics right now. What are they composed of? Well, it's variable. There are true plastics like polyethylene, polyester, polystyrene, but then there are other materials like tire wear particles, cellulose acetate, and cigarette butts. It's estimated that 8.3 billion metric tons of plastic have been produced to date. Most of that's accumulated. A very small percentage is either recycled or incinerated. So that 79% is basically going to landfills and in the natural environment. And where are we finding them? We're finding it virtually everywhere we look. Including the Arctic and Antarctic, we're finding microplastics, and in areas that you might expect. Plastic cups, great example. Our red Solo cups, our transparent cups, very few of these are being recycled. Our wastewater discharge, 50 to 100 to 15 million particles are discharged per day because we're not efficient at removing this. They're found in aquatic and terrestrial wildlife. Here you can see lots of plastics accumulated in the gut of this bird. And again, the most common true plastics. And they come in lots of shapes, fibers and fragments. Fibers are the most common form, the shape that we find. Now there are techniques that are going on. There's a new super enzyme that's being explored in the UK that can possibly break it down in a very efficient manner. So lots of different opportunities are going on right now, looking at ways to break down this plastic or to use more compostable plastics. But basically, they're everywhere. They come in lots of shapes, colors. The impacts to humans are unknown, but potentially problematic. And we need to examine both the direct impacts from them being taken in by wildlife, and indirect, because they absorb pollutants to them. In fact, we've been doing a study in Muskegon Lake where we've incubated microplastics in the water, and we find that they accumulate PFAS compounds, which I just talked about, 50 to 250 times their background concentration in the water. And so solutions exist, but currently the economic and social policies really limit their implementation. But it's a growing problem, and I'm sure all you need to do is pick up a newspaper, or if anybody picks up a newspaper anymore, or read online about this problem, you'll see about it. I'm not going to get into the politics of climate change and who's responsible, but there's no doubt that the Earth is warming, all right? Regardless of what the cause is, the Earth is warming. You cannot, well, I can't say you cannot dispute that, because actually I gave a talk last year in Grand Haven, and a woman came up to me, or 2 years ago in Grand Haven, a woman came up to me and said, this is all, some sort of conspiracy. And I assured her that the thermometer manufacturers around the globe are not conspiring to have warmer temperatures show up on their thermometers. But she didn't believe me, and she told me I needed to go see the Creation Museum in Kentucky. So I'll leave it at that. What are the impacts to aquatic ecosystems? Well, it's increasing our water temperature in our lakes, and it's having an impact on precipitation. If we look, there was a study done a few years ago where lakes were looked at around the world, and you can see if it's warmer colors, redder colors, you can see that they're increasing, and that's up to 1.3 degrees Celsius per decade. And a few are actually declining over time, but most of them are increasing. And they're increasing at a mean of about 1/3 of a degree per Celsius per decade, with a 95% confidence interval of 0.16 to half a degree Celsius. It's warming faster than air temperature and faster than ocean temperatures. So what's the consequence of lakes warming? We can see this here in the Great Lakes. This was July 9th of 2020. We can see how warm the lake temperatures were in Lake Michigan was up to 4 degrees Celsius warmer than the long-term average. And we saw this, in virtually all of the Great Lakes. And that's, obviously organisms are not evolved to deal with these warmer temperatures in these Great Lakes. What do we predict in terms of precipitation? On average, a slightly greater amount of precipitation. But the real problem is the frequency of extreme events are going to increase. And the reason for this is simple physics. For every degree that the atmosphere warms, it holds 7% more moisture. So when it does rain or snow, it's going to dump more of that moisture at that point. And this has implications for stormwater runoff and for stronger lake stratification. The precipitation events in the Great Lakes regions that are 2 to 2.5 inches, which is enough to really liberate the stormwater contaminants. And that's the reason is that our wastewater treatment plants are not built to handle storms of this magnitude. And so they end up discharging their stormwater without it all being treated into our rivers and lakes. And we're expecting the frequency of these events to increase over time by 50 to 120%. We've already seen this happening already. Here is the trend line for these one-day 100-year rainfall exceedances over the continental US. And we can see they've been increasing from 1950 through 2020 over time. And this means that these large storm events are running off our lands, running off our roads, and all taking these pollutants and entering into our lakes and streams. And this is how basically the heaviest 1% of all daily events from 1958 to 2012. And you can see that the Northeast and upper Midwest are having the greatest percentage of these heavy storm events, liberating these contaminants. In addition, we're aware that as the lakes warm, stratification, in the summer months, we have that warm top layer and the cold bottom layer. That the earlier it's going to stratify earlier, it's going to last longer. And as a consequence, what's going to happen is that bottom area in the summer months, because there's no longer atmospheric exchange between the surface and bottom waters, there's going to be less oxygen available, and we're going to have more periods of hypoxia and anoxia, where there's no dissolved oxygen, the so-called dead zones in these lakes. And those dead zones, again, what's happening is that warmer water levels allow these algal blooms to form. The cyanobacteria, the blue-green algae, like warm temperatures. That can kill off our fish. And it creates a habitat now where we can get new blue-green algal species in the Great Lakes, Cylindrus spermopsis, which is a toxin former that is found in subtropical habitats. And we found it here in the Great Lakes, and Muskegon Lake was the first observation that was ever seen in the Great Lakes. And that's because now, with the temperatures warming, we've now become amenable for some of these subtropical species to find their way into the Great Lakes and survive. People are concerned about water levels. And if we look at water levels in the Great Lakes, there are basically 3 factors that influence water levels. The loss occurs from evaporation. The amount coming in is equal to the amount going out. So that's not usually a major consequence, except in short-term events. And then the occurrence, what causes the water levels to go up are precipitation and runoff from land. So what we've seen here over time, since we've been recording levels, this is 1918 on the far left x-axis, and then we go up to 2020, current events on the upper right. And if we look at Lake Michigan and Huron over here, we can see that back in the early 2000s, up until about 2013, 2014, we had very low water levels, about what we had during the Dust Bowl era. And everybody was freaking out, although as we can see, water levels go up and go down. And that's all people were talking about, was how low the water levels are. Now, of course, everybody's talking about how high the water levels are. And what I preach when people ask me when are the water levels going to go down, and I tell them August 28th, 2021 at 4:30 p.m., I tell them, look, they go up, they go down. You just have to be patient. Of course, if your house is being threatened by high water levels, you don't have a lot of time to be patient. If we look at this over the last 3 years in some detail, we can see back in that period of early 2020, our water levels were exceeding the all-time highs of 1986, and now they've been replaced by 2020. But they've gone down since, as we've had more evaporation, and the projection by NOAA over the next 6 months is that they stay about a foot below the long-term, a foot below what the high levels were, but still about 1.5 to 2 feet above the long-term mean. Why were they so high? Well, basically, it was excess rain in Wisconsin. Michigan had about average precipitation events, but Wisconsin in the Milwaukee area, shown here, that dark green is above normal. They had way above normal, and all of that rain ended up flowing into Lake Michigan, which really accounted for a lot of that. We also had relatively cool temperatures in some of the areas and some ice formation, which limited the amount of evaporation. And then I'll move to dams, and then we'll kind of wrap up over a couple of last things. A lot of dams. We have a lot of dams on this planet. Over 45,000 large dams, which is considered a large dam is more than 50 feet high, and over 1 million smaller dams. And basically, they stop free-flowing rivers, which a lot of wildlife and fish and wildlife need. They need free-flowing rivers, and it alters hydrology behind the dams. There's temperature effects in these reservoirs. And if we look at the free-flowing rivers on the planet, the darker blue represents still free-flowing, and in the Amazon is one of the few places where we still have a long expanse of free-flowing rivers. But most of the large rivers are either red or orange, which means up to 50% of their area is no longer free-flowing. So only 30% of the rivers that are longer than 1,000 kilometers remain free-flowing on this planet through their entire length, and 23% flow uninterrupted to the ocean. And the impact is significant. If we look out in the Snake River here in Idaho, the salmon populations are being seriously impacted because they can no longer do their migration due to these very large dams. Fish ladders only work so well with these salmon populations. China has been building dams like there's no tomorrow. Most of these were built in the 50s and 60s, but they're still building them today, poorly maintained. Most of them are above flood control levels, so they're basically moving people out. The floods have affected over 50 million people, with 3.5 million people displaced, 150 dead or missing, and 41,000 homes destroyed. So just huge impacts in China. The Three Gorges Dam, way up the Yangtze River, you can see here, it's huge. When we talk about the impacts there, it's also significant. This dam is 7,500 feet long. It submerged 375 miles of upstream area. I think they wanted to basically exceed what we did with the Tennessee Valley Authority to show that they're the biggest at doing this. Displaced 1.3 million people. And some of the, that's the official Chinese line, but some people say it's closer to 2 million, and just with huge displacement involved. In the US, the Army Corps of Engineers maintains an inventory of more than 90,000 structures, and they suggest that about 15,000 of these are considered high hazard. And to be high hazard, the failure or misoperation is likely to cause at least one human life loss, according to their inventory. And of course, we've seen this. Here are the states facing a problem of high hazard dams based on the number of dams. Of course, one high hazard dam that fails is all you need to be a problem. But in terms of sheer number, the darker the blue, California, Missouri, Georgia are the worst cases. But we know we have problems here in Michigan. On May 20th last year, my birthday, 2 95-year-old dams on the Tittabawassee failed in sequence, and it resulted with Midland being under 9 feet of water. 90 feet. Here's the Edenville Dam collapsing, and here's Midland underwater. Just enormous, right in our own backyard. Really, really problematic. This dam failure resulted in over 2,500 buildings being damaged. $200 million in damages is the estimate. The state has hired a third dam inspector now. There's a task force that's reviewing dam safety in Michigan, and 6 experts just released their independent investigation of these Edenville and Sanford dam failures. So with all that problem, what are we doing about this, right? There's restoration going on a worldwide basis. In the United States, very large aquatic ecosystem restoration projects going on with federal and state support behind this. Great Lakes is, in terms of geography, is by far the largest. We look at some of these other large ones like the Everglades, it doesn't even fill half of Superior. Chesapeake Bay fills half of Michigan. Puget Sound, a small part of Lake Huron, and then down in North Carolina, a small part of Lake Erie. All of these are large scale, including the Gulf of Mexico and CalFed out in San Francisco Bay, or some other ones that are going on simultaneously. Let's talk about the Great Lakes for a second. We have the GLRI, or the Great Lakes Restoration Initiative. It was launched back in 2010. It actually started in 2004 with an executive order from President Bush at the time, basically to accelerate efforts to protect and restore the Great Lakes. It wanted, the desire was to provide additional resources to take care of the most critical long-term goals, and that was largely the areas of concern. Those were the polluted, toxic hotspots around the Great Lakes, of which they identified 43 to begin with. And then in 2012, they formed the Great Lakes Advisory Board to advise the administrator of the EPA of the basically of what's going on at the task force, and to provide advice both to the task force and to the administrator. The GLAB was basically let to sunset in 2018 under President Bush, but it was reformed in 2020. So the GLRI has received over that 10-year period about $3.5 billion worth of funds. Most of that has gone into delisting the areas of concern. Ironically, I can mention this since we're at the in Holland for most of you, or in the Holland area for most of you, that Lake Macatawa would have qualified as an area of concern, but back when they were forming these in the mid-1980s, the Holland area did not want to be on the list because it was a stigma to be on this list. The downside is that when the federal money became available to take care of these problems, it was specific only for federally designated areas of concern, and as a consequence, Lake Macatawa was no longer eligible for the funding. The next greatest area for funding was dealing with invasive species, and then non-point sources, habitat and species, then finally what I call the slice of misfit projects is this 11% for everything else. We funded over 5,000 projects to date. That $3.5 billion has been expended. Reformed the Great Lakes Advisory Board, of which I'm a member, and then we're currently working under Great Lakes Restoration Initiative Action Plan 3, which identifies the kinds of projects that can be funded. What are our future trends for water on a global basis? Well, I've identified three. There are many, but these trying to combine technical issues, politics, and economy and socioeconomic issues. We need to focus on climate change. I mean, that's just the reality. Most impacts associated with climate change deal with water in some way or another, whether it's agricultural production, sea level rises, wildfires, droughts, flood events. All of these are water related and climate change related. We know that half of the world's population will live within 200 kilometers of the coast, the global coast, by 2050. And sea level rise and storm surges are going to affect coastal communities. We're fortunate here in the United States to have the money and infrastructure to deal with this, to build seawalls or whatever the protective structures are. But many countries around the world don't have that luxury. We talk about Bangladesh. If sea level rises another meter, 1/3 of that country will be underwater. 1/3. It's wild. So these hard engineering structures can protect coastal communities against flooding, but hopefully new water modeling technologies will determine where our vulnerabilities are and have site-specific effective solutions so that we're not just building willy-nilly. Because building these hard structures does impact the ecology of these systems. The UN predicts that the world's population will go from 8 billion to 9 billion by 2050. That's only 30 years away. And that our global food production is going to need to increase by 70% to feed our planet. And that means we're going to have either more arable land for crop production. It certainly means we're going to have more extensive and efficient irrigation to water these plants. And that creates a real challenge. Where does that water come from? And will we have enough water left over for our natural ecosystems? So we need efficient irrigation management, risk management to our sediment so our soils don't erode, flood warning systems, and precise farming systems. We're developing right now, working on developing an early warning system in the Great Lakes so that not just for climate change related problems, but for other problems that either we know exist or don't even know exist yet, the unknown problems, so that we can have a system in place rather than acting reactively to these problems, start acting proactively. And then finally, we need to think about, from an economic perspective, dealing with wastewater as a circular issue, not a linear issue. Traditionally, we deal with investment planning, design and operation around water in linear traditions, in linear mindsets. But in fact, it's possible that this water can be reused. In fact, it should be reused, and in different parts of the planet, it is being reused. Basically, a lot of the wastewater can be recovered, either take some of those elements like phosphorus or nutrients like nitrogen out of the system and reuse it, and then take that gray water and use that gray water to flush our toilets or sprinkle our lawns. It's absurd that we are flushing 2 to 5 gallons every time we flush a toilet with perfectly good potable drinking water. I mean, what a waste of water. So with that, hopefully, I give you some ideas of what the major challenges are around water, around the planet, and then some of the potential solutions that are out there as well. And I will be happy, with the time remaining, to take any questions that you might have. And thank you for listening. I know I covered a lot of material quickly, but I am available either now or afterwards if you want to contact me to go into more detail on any of these issues. And I'll turn it back to Susan, who's going to be moderating.
Hey, let's see. We have a couple questions in the chat. The first one being, are desalination plants useful?
So yes, desalination plants are useful. The major issue with desal is that it's very energy intensive. And so in countries that don't have the available financial wherewithal to run these plants because of the energy, it's not going to work. But in countries that do, it is an alternative. And in fact, they're being built, quite quickly in some parts of the country. Now, having said that, several were built about 20 years ago in California. And it turned out that it was actually cheaper to import water, using it from the Colorado River than it was to run the plants. And so they were mothballed. So it really depends. It's that fine line where the economics justify the running and energy intensive use of these desal plants relative to the need for fresh water. Over time, as water becomes less and less of fresh water becomes less and less available, and the economics of running them become less energy intensive, I think we'll see more desal plants. Of course, then the question becomes, what do we do with all of the brine that's produced from these desal plants? Really, really intensive salinity. And how do we dispose of that without causing other economic and ecological problems? We're always bit in the butt by these, secondary problems that we didn't anticipate.
Thank you. What is the source of BPW's water?
I have no idea. What is BPW? Help me.
Holland Board of Public Works, and it's Lake Michigan.
Thank you. Thank you.
The water pumping and whatever it is, purification and so forth occurs in a plant right across from Tunnel Park.
Right. I know where the site is. So yeah, they get their water from Lake Michigan, as does quite a bit. So when we talk about the water problems in Ottawa County, one of the potential solutions is actually extending the municipal mains to get out into the middle part of the county where they currently use well water. But that's extremely expensive to extend those mains, and who's going to pay for that? We're talking millions and millions of dollars. And so, that's why the Ottawa County the planning department is looking at that. They're looking at the utilities. They're looking at what that would cost, and whether this is even financially reasonable or doable or tractable or not.
Okay, that's all I have in the chat. Is there a specific line of question that you'd like to pose to the group, or would anybody like to unmute themselves?
Go ahead, Jim.
When you showed the water level volatility chart, it looked like Lake Ontario was substantially less volatile than the other lakes? Why would that be?
Because there's a water control dam on Lake Ontario, which helps do that. So, basically, when you have that regulatory, when you have that regulatory ability, you can keep it within a certain level. Makes it easier.
Well, is that a good thing? Should the other Great Lakes do the same thing?
Well, I would argue that they shouldn't, but that's my own personal opinion. When water levels were very low, back in the early 2000s, there was actually a proposal to build a dam across the St. Clair River, basically to hold the water level up, not necessarily to regulate the water levels, but that was seriously considered, although most of us thought that was crazy because it would cost so much money, and by the time it was ever built, the water levels would come back up again, which of course they have. Water levels go up and down, and there's only so much you can do from a regulatory perspective. Ontario being down at the bottom tends to have more ability to regulate that water, but when you get further up, it's very difficult. Superior has, in theory, a regulatory ability through the lock and dam on the St. Mary's River, but it still gets high and low water levels simply because it's not sufficient to deal with that. Mother Nature ultimately has the control over the water levels in the lakes.
Thank you.
Thank you for the question.
I have a question. This is Donna Bogle. It's not a question, actually. It's just sort of a community announcement. On the 24th of April, apparently the entire state of Michigan has a water cleanup scheduled. I know that the Rotary clubs across the state are involved in this. So this is a community announcement, and if anybody would like to schedule that and be part of a crew that cleans the waters of Michigan, it's along streams, along lakes, and along the shores of the Great Lakes.
Thank you, Donna.
Thank you. I have a couple comment and questions in the chat. I noticed this morning that Hope uses permeable pavers on all of their college sidewalks in areas that are recent. Should institutions spend the money to convert more of their concrete, or does that not make enough difference to get the water into the aquifer instead of down a storm drain?
That's a great question. So, as we've been building more and more of what we call impervious surfaces, all that water can't get into the aquifer to be recharged. It goes into our storm drains, which then goes directly out into our lakes and streams, not into our groundwater. And so the more that we can have pervious pavement, like these pavers that the question mentioned on Hope College, that's a great thing. Most municipalities are trying to avoid that, even though it makes a lot of sense, simply because the maintenance costs are quite high. What happens is that the sediment will clog between those pores in the pervious pavement. So it requires the municipalities, or in this case, Hope College facilities people, to go out and suck out the sediment that's clogging the pavement. So if you have the ability to do that, and it's cost efficient to do that, I would certainly encourage that. The alternative is to be building more rain gardens and basically swales that holds the water and lets it percolate naturally. But wherever it's possible to basically have these kinds of pervious places or curb cuts so that the water, instead of going off the impervious surface into a storm drain, goes to basically a swale or a rain garden, I think that's great. And it also acts as a natural filter to take out pollutants before it hits the lakes and streams. So absolutely, if it can be done, then it should be. But most of the time that I've tried to convince municipalities about the virtues of pervious pavement, I've been told that the economics just don't work.
Thank you. Tom commented that he really enjoyed the presentation and asks, how helpful are so-called low flush toilets?
I think everybody should have a low flush toilet. Absolutely. There's no reason to have flush 5 gallons. No matter how prodigious you are in producing waste, 5 gallons is not necessary to flush it down the toilet. So yeah, you could have a low flush toilet, or you can put a brick in your holding tank, displace the water so it doesn't require quite as much water. There's all sorts of ways to deal with this without having to replace your entire toilet to do that. But 2 to 2.5 gallons is more than enough. And you can go to parts of Europe, particularly Northern Europe, where they have these toilets that are basically taking the wastewater. It's separating the wastewater on site in this decentralized system, and basically taking your solid waste and composting it, taking your liquid waste and treating it, and then it's being put out into your garden. I mean, in America, we have this real yuck factor about that kind of stuff. But until we reach that point where we no longer have adequate water supplies, it's really difficult to convince people to do that. Where there's already a water crisis, it becomes a lot easier.
Mm-hmm. Thank you for that. There's nothing further in the chat right now. So if anyone wants to open
I have
their
a
mic.
question. My name is Al. I am a debate coach. And the National High School Debate topic this coming season is going to be increasing protection of water resources in the United States. I'm wondering what two or three of the best topics that you think we could go into.
Oh, great question, Al. Well, I think certainly one of them is going to be water supply, right? So, here's an interesting anecdote, which you may be able to use. It's obviously much more prevalent. Water supply issues are much more prevalent out in the arid Southwest than they are here, but it's a problem across the nation. The Colorado River, which is the main water source for most of Western US, when the water was allocated back in the 1910 decade for the Colorado River, they ended up having a very wet decade. So they over allocated the amount of water that would normally be available in the Colorado River. So most years now, the Colorado River never makes the Gulf of California. It's extracted at such a degree that it dries up before it ever hits the Gulf of California. So what are people doing about this? How can you deal with this problem? And with climate change, the snowpack is declining. There's simply not enough fresh water to deal with all of the demands that are being placed on it for much of the population in this country. So how do you convince people to conserve water? What are going to be the long-term consequences of doing this? Do we change our agricultural practices so that we're not using water in areas where water, we're growing crops that are really water intensive? Almonds. Why are we growing almonds or rice in California? It's absurd. So how do we deal with that from a multi-dimensional perspective? The second one is contaminants, emerging contaminants. We didn't even know PFAS was a problem until 10 years ago. And now we're finding it everywhere. But that's one we know about. What about the unknown ones that are still lurking out there? What are we going to do about that? Are we going to start doing monitoring? And then who pays for it? As we have these huge plumes of problems, are we going to tax people about this? Are we going to cause the government to pay for this? All the Air Force bases here in Michigan, they basically, say, not me, because we don't have the money to do this and we don't want to set a precedent. So I think the cost of this, who pays for it, and how do we find this? And then the third one I would throw out there is just climate change impacts that are changing the way that water is available in this country. And are we going to start taking this seriously? And how are we going to respond to this? I tell my class all the time, the technical solutions are usually the easiest ones. It's the political and social and economic issues that are the real stumbling blocks in terms of us making progress. So when people ask me, what is the one thing that they can do to make a difference when it comes to these kinds of environmental issues? I tell them, vote wisely. That is the number one thing you can do. Thanks for the question. And good luck. Please, I'd be really curious to know how you guys do and what topics you end up picking.
Maybe I could keep you informed on it a little bit. Thanks so much for the answers.
I'd love to hear back from you.
I have a question about the Arctic thawing. What's going to happen when that water starts coming down the shield, the Canadian Shield?
It's an interesting question, Barb. So the permafrost that is basically thawing out across the Arctic tundra, the main problem there isn't the water coming down, in flooding areas. The main problem is the methane that is being released as the carbon gets oxidized from what was traditionally frozen. And methane, even though the biggest gas in the atmosphere in terms of mass is carbon dioxide. The amount of heat that's retained by methane is actually 30 times greater than a CO2 molecule. So more methane going up into the atmosphere is actually going to cause more radiation heating in the atmosphere than the carbon dioxide. So that big flush of methane is really a problem. The problem in melting is the Greenland ice sheet. Because, and I wish I had a slide for this because it's really hard to describe this orally instead of visually, but the oceans basically form a conveyor belt. They move, they're not static, they move on this conveyor belt. So think about the Gulf Stream. The Gulf Stream is coming off the Florida and Southeast Atlantic coast, and then warm water, it works its way up into Northern Europe. The reason why Scandinavia is relatively warm, at that latitude, Scandinavia should be frozen all the time, but it's relatively warm because that Gulf Stream helps warm it. And then that conveyor belt turns east towards Greenland and Labrador, and it gets cold again and it sinks. Now what happens is as Greenland starts to melt, that water, that fresh water is hitting that conveyor belt of water. And the question is, will it stop the conveyor belt? If it does, then the Gulf Stream might be stopped and we would no longer have that water that plunges and works its way all the way back down to Antarctic before it starts migrating towards the Indian Ocean. That might put Northern Europe back into a little ice age again. And nobody knows for sure. We've got all these buoys out in that area. There's this one area off of Greenland, between Greenland and Norway, and Finland, where we're putting all of these buoys to monitor this conveyor belt to make at different depths, from surface down to 5,000–10,000 feet, to figure out what's going on there, because that is considered a trigger point in the ocean circulation patterns. That's much more than you wanted from this question, but it's a really relevant point when it comes to monitoring climate change on the planet. I've overwhelmed you. I apologize.
Does anybody else have any questions? I see a few people with their mics opened up, so speak up if you want to continue this conversation. We have about 10 minutes left in the class, or we can wrap early.
Alan, why does Holland not get its drinking water from Lake Michigan when a community like South Haven does, and I would guess other communities along the west shore of Michigan do?
I thought Holland does get its water from.
Yes, to clarify, Holland gets all of its water, BPW gets all its water from a water purification plant just north of, part of Tunnel Park. There's a green area on the north side of Tunnel Park, which is over the pipes that come from the pump house.
Okay, thank you for clarifying that.
And just to expand it a little further, there's a Wyoming water plant and then a Grand Rapids water plant. It's kind of up the coast, and they're all interconnected for emergency purposes with pipes between them so they can support one another in an emergency.
Thank you.
I have a question. Do you see any threat in the future from other areas wanting to divert Great Lakes water to serve their own needs, supply needs?
Yeah, that's a great question. The biggest threat right now to diversion of Great Lakes water is actually not from Arizona or New Mexico. It's actually these straddling communities along the Great Lakes Basin, like Waukesha in Wisconsin. And actually a community just south of Chicago now in Illinois. So we have the Great Lakes Compact, and that is a federally authorized legislation that prevents large water withdrawal from the Great Lakes. And in fact, I would not worry about Arizona or New Mexico or California because the cost of pumping the water is so prohibitive in terms of the energy demands to take the water over there, that it's actually cheaper. Somebody did this economic analysis. It's actually cheaper to haul an iceberg off of Alaska and take it down to Santa Barbara, melt it and process it off of California than it would be to pump water from the Great Lakes. But it wouldn't happen due to legislative authority, but the economics tend to be the stronger regulatory authority anyway. But these straddling communities can be eligible if they meet a set of criteria. And if all 8 Great Lakes governors and the 2 provincial ministers all agree that that water can be used, which is how Waukesha got their approval to do that. Now, they have to return the water back to the Great Lakes after they use it. And in theory, in environmentally safe, I can't remember the exact language of the legislation, but basically an environmentally safe way. But of course, it's impacted to some degree. And so it really depends on the use. Now, these are not huge amounts of water when you talk about the whole hydrologic water cycle for the Great Lakes. But on a localized basis, it's a problem. And then people are concerned about setting precedent that for these straddling communities, they might start making all of these requests. So that's really where the greatest interest is right now. And the greatest vigilance is around these straddling communities. Does that make sense?
Yes. Yeah. The thing that came to mind too is the Ogallala aquifer out in the plains, which is being depleted pretty rapidly, I understand.
Very rapidly. Yeah, that's a major concern, and that's a major aquifer, and that's one of it's a great example of what we should not do in the future, and use that as an example for our generation and future generations about how basically using groundwater in a non-sustainable fashion. So really the focus here in Ottawa County on our groundwater issues is on sustainability. We want to make sure that our way of life, and I am an Ottawa County resident myself, even though I work in Muskegon, we want to make sure that our groundwater is used in sustainable fashions. The example I use quite often, and this isn't even water, this is about our ancient eastern white pine forest. When the lumber barons came here to Muskegon and to Holland, in the 1850s and 1860s, and they started chopping down all of these trees, they said there's enough lumber here to last a century. And they basically wiped it out in 9 years. Talk about non-sustainable use of a natural resource. That is how we don't want to behave in the future. We want to make sure that our water here, water supply, our water quantity, and our water quality is here for future generations as well. And so that's why we need wise policies now, and we need the research and the monitoring and the education and outreach so that communities and individuals understand the implications of being non-sustainable, which are, they're profound.
This is Case Molly. I did
wondering
want to come to the defense of the Ogallala Reef because they've done a lot. There is so much legislation regarding that in the state of Kansas. I moved here from Kansas, and there is so much discussion about that. It's something will be done, but don't ask me what, because they can't figure out what to do.
Well, Kay, that's a great point, but they're acting reactively to a problem that's
Right.
already established. What we want to do is be proactive so that we never get to the point where they are in Kansas about the Ogallala, and that's why we're trying to really address this problem now before it becomes more of a problem than it already is.
What is the impact of fracking on this aquifer out in Nebraska? I can't say the word either.
Aquifer. Oh, for Ogallala. I don't know how much fracking is going on out there. I can tell you fracking here in Michigan is almost all exclusively in the northern part of the Lower Peninsula. So we don't have that issue around here. But certainly
No.
up in Antrim County, it's very, it's a big issue up in that region. And fracking is occurring where they do frack is very deep, and so it tends not to affect, where we get most of our water here in terms of the glacial till.
No. Okay, thank you.
Thank you. Are we good, Susan?
We don't currently have anything else in the chat. Does anybody have any last minute comments or questions? We have about 4 more minutes left, or we can wrap.
Do you have any opinion on the risks of the Enbridge Line 5 rupturing?
I purposefully avoided that topic. We all want to protect the Great Lakes. I firmly get that. On the other hand, we all need energy. So I don't know enough about, whether the tunnel makes sense as a sufficient alternative. I don't know enough about whether the alternatives that they propose to get the propane to the different people that need it is going to create new problems. Everybody says, well, more trucks on the road, more carbon dioxide being emitted. Somebody, everybody's doing it from their own bias, right? And that makes perfect sense. We're humans. Somebody out there as a third party needs to do an analysis looking at it from a full accounting perspective, all of the different dimensions. If the Great Lakes were impacted, what would be the cost of cleanup and, obviously the environmental costs? And this is non-market based because we don't have a market for that water quality issue. Somebody needs to look at it from an energy perspective. Would people really be put out of energy? I mean, we don't want anybody going freezing at night. Will agriculture be impacted? That it's a huge, huge question. But until that happens, until I see the data and the science that I know is objective, I really don't feel comfortable making an opinion on there. Other than, it's a really tough question. I think people are basically giving their opinions off the cuff, and I think that's really wrong. I withhold judgment until I know more.
I was amazed by the heat thing that you showed for the Great Lakes, and even Lake Superior getting warm around the edges. That's unbelievable. But I was wondering what kind of environmental effect that has in terms of the fishes.
Well, the fishes are definitely going to be impacted, no doubt about it. The biggest environmental effect is that Duluth, for the first time in its history, had a harmful algal bloom. I mean, it was just never warm enough for the blue-green algae to take off. And after that warming event in 2020, they had their first documented toxic harmful algal bloom. So, there are impacts, and this is the kind of information that we do have confidence about, and so I don't mind talking about this. That this is a significant issue. I didn't show it, and unfortunately, but I have a great graphic if anybody wants to contact me that shows the planetary warming over the last century, and as it warms, it goes color. It gets redder and redder, and oh my God, it is so alarming to see what happened, particularly in the Arctic area. When we were talking about the permafrost melting. It is amazing. The Arctic is the most sensitive area of the planet right now, and it's warming at twice as fast as anywhere else on this planet. And unless you're working up there, it's just a news bite. You don't really experience it. But it's alarming. We are changing the basic nature of this planet. But weather's local,
Any comments about the Nestle plant and the effects of the groundwater in the area up there, the farmers and that?
Well, yeah, I mean, it's been shown that where those new pumps are, that they are impacting those small tributaries, no doubt about that, despite what they say. I mean, we have data that show that the invertebrate communities have been impacted because some of these smaller streams are going dry. The real question is, now that they've sold or in the process of selling their drinking water facilities, what will the new owners do? Will they shut it down, or will they continue, or will they retract, will they expand? Nobody knows for sure what their policies are going to be, and so that's where we're looking at right now to see what the impacts are. The one thing I do say about Nestle, and then we can stop this, and Susan, I'm sure, is anxious to get off, is that I try and teach. I use Nestle as a case study for my class. And I say, it's horrible that, we're impacting the dead stream, which is the name of the stream where the major sanctuary springs are, and pike are being impacted. On the other hand, the median household income in Mecosta County is almost $16,000. Median household income, $16,000 a year. And the Nestle plant jobs are paying $37,000 a year. I am not saying that you can equate environmental impact with economic household income, but I do think you need to think of this in a larger view of the world. And when you start balancing this, it's not just that a couple of streams are being impacted, it's that people's quality of life are being affected as well. So the world is not black and white. The world is shades of gray. And that's what I hope to leave my students with, and hopefully leave all of you with as well, although I'm sure most of you already know that. That these are tough questions, and we need to look at them from a multi-dimensional perspective. And listen to the other side. We need to find where there's common ground and not be polarized, which is a tendency right now. It's really sad. Science helps inform policy, but it doesn't dictate policy. I learned that working in the Everglades before I came here. a very litigious and a very politically sensitive environment. And so I hope that our resource managers can take the best information that we can provide and make wise decisions, which is why it's important to vote wisely. I'll leave on that soapbox.
And thank you very much. I'm certainly not anxious to wrap this discussion because it is so important, has so much gravity, but we do thank you for your time. And I have several comments in the chat. This excellent, informative presentation. Thank you. Lots of exclamation points. Another thank you. Excellent presentation. We do appreciate your contribution to HASP and just helping us become more aware of these issues. So if there's nothing else, I will go ahead and wrap the class and wish you all a great afternoon and enjoy the sunshine.
Thanks, everybody.
Okay.
Terrific. Thank you so much.
Thank you very much.
Thank you, Kay.
Thanks, Kay.
Alan, do you want to hang for just a second? I just
Sure.
want to just comment that I provided Al with your email address because you had mentioned to each other that you wanted to possibly get some feedback on his competition. And then another person, Betsy York, asked if she could contact you, and I also provided your email address.
Absolutely.
And I had a question about that email address. It ends with MAA rather than MAN. I'm wondering, is that correct?
That is correct.
Okay.
Grand Valley takes the last letter and puts the first letter of the first name in it. So that's why it's Ma. It's not because I have a mother fixation, I assure you.
Thanks so much.
We're a little simpler here at Hope. I just have Timmer. That's it.
I like Hope. I like Hope.
Actually, I got
friends
lucky
down there.
with that. So everyone, I'm going to go ahead and close the class again. And Kay, thank you. Alan, thank you so much. And
My pleasure. Thanks for
we
the great
appreciate it.
questions. Really appreciate it. Always talking to HASP. It's always provocative.
Take
ya.
care. Bye, everyone.